Dima Trubitsyn.
Hello.
And his story about a really special project CityAir. So, Dima, just talk.
Good evening, everyone. The first question I'd like to ask before we start, is there anybody who doesn't speak Russian? So everyone speak. Yeah, okay. So that means that it will be a little bit awkward speaking English in this auditory, but yeah, we'll try. Yeah, yeah, yeah. I will think that, for example, you don't speak Russian, and I will tell it for you. Okay, okay. Thank you very much. Um, so, well, let's start. It's not continuous presentation. It's just a number of different points, different illustrations about air quality problem itself, and about CityAir as a platform, as our project. Um, so let's start with a few very obvious statements and points. It's pretty understandable that atmosphere and ambient air is a very important part of the environment. Again, it's obvious that air pollutions in ambient air or in atmosphere can affect significantly all living organisms on the Earth. On the other hand, very many people live in big cities where air quality is not that good as it could be. In the cities, air is polluted with various different substances like carbon monoxide, nitrogen dioxide, ozone, some different molecular compounds, and I can see here we have a mistake. I mean that this slide doesn't contain information about particles of different size, like PM2.5, PM10. So air in the cities is very much polluted. Is it really important that air is polluted, and how much does it affect us, our health, and our lives? According to World Health Organization, air pollutants are responsible for various diseases, and actually this picture is frightening because, for example, even a quarter of all heart attacks or deaths connected to the heart diseases is connected to low air quality, especially to the concentrations of particles in the air. So if we remove different particles from the air of the cities, we will have 25% less numbers of deaths connected to heart disease and strokes and so on. So it's very, very important subject, air quality or air pollutants in the air of the cities. So it's just illustration of this point. Another bunch of numbers. It's estimated then approximately 4 million people die every year because of polluted ambient air. So it's quite big numbers, and it's big losses for society. Another interesting subject is connected to the mechanism of this influence. I mean that we know that World Health Organization knows that air pollutants are responsible for all these diseases and different problems. But what are the mechanisms of this influence? It's another subject, and probably we will not discuss it today, but a lot of scientists, all around the world, are working on this problem. And in our project, we have partners in different different countries who are working on this problem. We provide them data, about air quality in the cities, and they return us some information about well, how one or another pollutant affect health or life. Okay, what can be done with this problem? Well, I'm speaking about problem of low air quality and problem of big numbers of deaths connected to this air quality, low air quality. The first step is to define the problem. It's the first step to solve the problem is to precisely define the problem. It means that we have to obtain a lot of accurate data about air quality in the cities. We have to obtain data with high resolution and high precision to be able to do something with air quality, to be able to apply different methods, to apply different technologies to, for example, to remove pollutants or to minimize effects of these pollutants to our health. So the first step is to measure, and that means that one day global air quality monitoring system should appear. And it's well, one of the main reasons we are working on our CityAir. What do we have today? We not as a CityAir, but we as a, well, as a people. Actually, there are different, several projects, several aggregators of public data about air quality on the Earth. But this it's not, it's very limited resource, because the resolution of this data is quite low. I mean that it's not possible to distinguish one building and another building. I mean that the resolution of these maps is quite low, like 5 kilometers or more. That's why we can see details in the cities. We can't understand how exactly this continuous map of air quality behave in the city. So it's not sufficient resources. And what do we need? Again, well, I've already mentioned that we have to build, well, to invent high-resolution continuous air quality maps. We have to obtain resolution as high as like 100 meters to distinguish between buildings and individual, for example, roads. Speaking about well, services for people. We have to provide short and long-term forecasts, and its main 2 points. So these well, global high-resolution, high-quality air quality monitoring system should appear. How can it? But it's very difficult. It's a really ambitious problem, because just imagine what should we do to provide this high resolution. Speaking about, well, 100 meters. So you point at any you touch any point on the Earth, and system should reply and tell you what is the concentration of all pollutants in this point. It's very difficult. Maybe you have well, a lot of sensors, small sensors connected to different buildings and so on, and maybe you have apply some computational mathematical models to predict. So it's very ambitious problem, and it's very difficult to solve this problem inside one small project or one small company. So what can we do to achieve that? So to solve this problem, to build this air quality monitoring system. We decide that we will create a state-of-art platform which will be attractive for different organizations for building their own monitoring systems. For example, well, a lot of government structures, they buy our systems, so they build their own monitoring networks using our platform, and it allows us to expand our network and to enlarge amount of information we obtain. So we have to provide aggregation of data from all around the world. Well, at hardware and at software level, it's also very important. And the third and very important part is that we have to engage a lot of researchers all around the world, because we have a lot of very difficult and challenging problems we have to solve. It's impossible to do it, well, alone, but we can do it involving a lot of researchers all around the world. Is it possible? Yes, it is, because all researchers, they need data, and we can provide this data. Well, they need to publish publish papers, and they need to obtain different grants, and that's why they need industrial partner, and so it's a win-win well situation. What is CityAir well today? Just few words about well our platform, yeah, just few slides. So we have three main parts of our platform. The first one is small air quality monitoring stations, monitoring sensors. It's the one hardware part of our platform. The second one is well, data analysis, modeling, and forecasting. It's quite difficult, complicated mathematics, computational well, science, and so on. It's another very, very important part of the platform. And the third one is, well, we call it just a data visualization. This is illustration of, well, how our small stations look. It's main station, which has different sensors on board, like temperature, humidity, pressure, and sensors for measuring concentration of particles like PM2.5, PM10. And also we have additional modules which allow to measure carbon monoxide, nitrogen dioxide, and so on. So it's just pictures. So we have this hardware. And by the way, to develop this hardware, we combine our efforts with another company, and CityAir. By the way, CityAir is it's joint project of two companies, TION and Uniscan. So Uniscan Research is responsible for, at least for for this hardware. The second part, modeling and forecasting, just illustration and just few words that we can build continuous maps, and we can provide forecasts. Now we can provide short-term forecast like 24, maybe 48 hours ahead. And well, just illustration of data visualization. It's very, very important part, because there are again, there are different competitors, and so probably they even have some data, but they cannot provide useful and user-friendly access to this data. It's very important for us, so that's why we well, we are talking about data visualization as another very important part of the project. And just a few pictures of how it looks in real life. It's our stations in different buildings. It's in Novosibirsk, and I believe that these pictures from Moscow. By the way, now we have our stations in well, few tens of cities in different countries, and we have even in New York we have our first well, station. We start our well, our movement to the Western markets. But air quality monitoring business requires to be very, so we have to be, we have to be very well. Sorry, I will try to explain what do I mean. I mean that when you have data about air quality in the cities, it can be dangerous for you as a business, because, for example, air quality data with harsh resolution may affect different markets. For example, real estate market. And that's why we have to protect ourselves, not to be killed by those guys who build well, houses in regions with not very good ecology. It's important. It's not a joke. Also, air quality data may be used for military purposes. For example, and we know that one of our competitors who moved to United States, he was well, the leader of this project, he was found by FBI and was asked different questions about why do you measure air quality. Well, so it's another risk. And also, of course, air quality data may intimidate mass audience because it's quite sensitive subject in any government in any country. So that's why we are working on choosing the right tone of voice and engaging researchers and policymakers to find solutions. Our position is simple: air quality data is our opportunity to live longer. So that's why we have not to be, like Greenpeace. So they cry about air quality. It's not a good approach because you will not find friends, but you will find enemies in government and so on. So you have to be very cautious. Okay, few words about our cases, our business cases. Of course, we are talking about, big deal. We are talking about global air quality monitoring system, but this project is but now we are already business. We sell our solutions, and just a few examples. The first example case is the following. We believe and we hope that CityAir will be a national air quality monitoring platform in Russian Federation. On this photo, you can see this guy, and he's Minister of Construction and Housing of the Russian Federation, Yakushev, and here is CityAir, and we sell him all our ideas. And now we are in pilots with different government structures, and we provide some tests, and we believe that we will be maybe not the only, but one of the platform for air quality monitoring system in Russian Federation. It's a big deal. Another case is very interesting. It's now we're working on experimental monitoring network in Skolkovo. It will be extremely dense network. I mean that we will have tens, maybe hundreds of sensors on 6 square kilometers, and this will allow us to provide different tests, different experiments, and we will do some useful experiments on high resolution. Yeah, so we will move toward high resolution maps. It's very interesting, and Skolkovo helps us to deploy the network, and we believe that by the autumn of this year we will be ready. Another interesting and unexpected application is the following. We can use our air quality monitoring system to control air quality in huge objects. This is a model of recreation center, Dream Island, which will build in Moscow in next year, I believe, and it's the largest park in Europe and maybe in the world. It's like part of the city covered with transparent roof, and they have to control air quality inside. If I can enlarge the picture, you will see that they have very small models of people inside. So it's like this size is like 30 meters, so it's very big. And now we have a contract with them, and now we build some computation models of this building, and the next step we will provide air quality monitoring system, and the next step we will control all ventilation and air conditioning systems in this building in order to provide the maximum air quality and simultaneously to provide the lowest energy consumption as possible, because only like 30 megawatts is consumed to provide air quality inside this object. Another interesting case, it was unexpected for us. It's developers, so guys who build and sell very expensive houses for for people. And so they usually buy 2 stations of air quality monitoring. One of them they place outside, another they place inside the building, and also they buy air cleaning system. And if the house is located in ecologically safe place, they can show that they are in good place, and that's why they can sell more expensive. So they can rise the price, right? And if the house is in ecologically not that good place, they can show that anyway inside the building air quality is high. And that's why they are very interested in this combination of different hardware of air quality monitoring stations and of air cleaners. It's and this approach and this market, it's small, but still it allows us to enlarge our network in, for example, in Moscow. And we do not pay for this network. So developers pay for this. Another, again, unexpected. So we have a lot of unexpected applications. Is the third unexpected application. It's weather forecast for different companies. For example, for windy application. It's quite famous and popular application for different sportsmen, like for kiters, for surfers, windsurfers. So these guys, windy, they sell weather forecast. And they asked us to improve the resolution of this weather forecast. And we managed to provide high resolution of and high precision of in prediction of the velocity and direction of the wind. It's very important, and it's also very important for our project because to be able to predict the field of different pollutants in the air, you have to predict the wind, and it's so these tasks are connected very much. So it's like probably it's the weather. Above the Eastern Europe, and here's the first of the pictures. So it's a continuous map of pollutants above the Moscow, just to illustrate. And another application or case, it's we like it very much. At least we like to speak about it very much. It's our collaboration with MIT Sensible City Lab. And hopefully by the autumn of this year, we will deploy air quality monitoring network in New York. And guys from MIT hopefully will use our network to compare our data with some another sources of data about air quality. So they working on different from us methods of air quality monitoring, and they need another network to compare their methods with some reliable methods. So this case will open doors to Western markets for us. I think that's all. And thank you for attention, and please feel free to ask questions, or maybe you have ideas what opportunities, who and why will pay for the data. So now we understand who and why pay for hardware, and we sell a lot of hardware, but we believe that if we speak about CityAir as a business, we believe that in few years we will be able to pay to sell data. So, feel free to generate ideas about who will pay for it. Yeah, thank you very much. That's all.
Thank you, Dima, for breaking the ice. Yeah, thank you, really huge thanks. But guys, if you have a question, any question, just use this microphone to make some record for Conveerum.
Dmitry, can you explain how you come to this idea to measure CityAir in different places?
Yes, I believe I can. Basically, this idea was born inside Tion as a company, and we we develop and produce air cleaning systems. And again, one day we understood that to to sell air cleaning systems, we have to measure pollutants in the air. It's very important. It's very important to define the problem, and it's very important to to prove that your air cleaners work well. And that's why we understand that we need a system which will be we can use to measure air quality, to measure pollutants. And now we have two systems. One is inside Tion. We call it Magic Air. It's a system for air quality monitoring inside the room. And so another system is CityAir. But again, one day we understood that CityAir could be could be business itself, because we not only use it to to sell different solutions, air cleaning solutions, but it could be business itself. And that day we separated CityAir from Tion, and now it's joint project with Tion and Uniscan Research. So I hope I answered your question.
Thank you. Good day. Thank you for your speech. It was very interesting, and a lot of things which I really wanted to know. Now I know it, because I'm like a person of I want to be a zero waste person. Maybe it will be in this year or maybe next year, because it's not very easy in Russia. But for example, in Europe, it's very huge things which right now works for this style of life. And my question about your system is how we can use, for example, Greenpeace, or I don't know, maybe different person which want to live in a clean world, how we can use these actually facts with numbers from your company, from your sources, how we will use it for government. For example, maybe we can say, look, this factory, or for example, this big living complex, very dirty for our planet, or something like this. So is it legal for users for to strike with government, to strike against this air pollution and earth, I don't know, dirt, air, and dirt living?
Yeah, thank you very much for your question, but it's two questions. How can we use, and is it legal? So it's two different questions. It is almost legal now, and it will be absolutely legal in few months, because in Russia you have to get all necessary licenses and other documents, and they are almost ready for this system to be official, or to be legal. Illegal in terms of using results in, I don't know, in courts and different places. And how can we use? It's a very, very good question. For example, and I will probably I will answer in the following way. Speaking about citizens, for example, we understand two scenarios. For example, you choose the place where you're going to live, or where you're going to rent place to live. You can use our service to distinguish one place from another place. And this system will show you the numbers, how good or how not very good the place is, and you can compare. And now, by the way, now we in connection with Booking.com, and we suggest them to use our data in future to provide service for I don't know, for choosing ecologically most safety hotel, for example. So it's one way to use this data. The second way is the following. For example, you every day you go from home to work and back, and you have some road, right? So you can choose the ecologically most safe road. But it's very important. For example, in England, maybe 2 years ago, the guys, very good team, so they provided a correspondent experiment. So they choose different roads. The difference in terms of time was like maybe 15 minutes, but the exposure of air pollutants, well, it was 10 times lower and 10 times higher. It's very important. Okay, and speaking about, for example, government or city managers, they can use this system to simulate the results or effects of different solutions. For example, we decide to place factory here. What will it mean in terms of ecology? You can see it using our system. Or for example, traffic changed. So now we built new bridge over the river. What results we will have? So this system will help to analyze. And another application, using this system, we can try to find the source of pollutants. It's again, it's mathematics, but it's not complicated. I mean, monitoring. If we have a lot of sensors all around the city, we can understand who is responsible for all this. So it's another way to use the system. I hope I answered.
Thank you very much. I would say you're so brave to start this big deal. And the question is, I think you have a lot of data about our city. And what about our city? So what's the best region? Is Akademgorodok is the best or not? Maybe the Ilsovsky region is the best. So do you have some data about our city? Maybe of the different city, what's the worst place to live? The worst city to live in the world, something like this.
Yeah, thank you for your question. Yeah, we have our monitoring systems in different cities. We have it in Novosibirsk also. I will try to. It's our site, and I will try to show you. One moment, please. Yeah, it's Novosibirsk. We have like 10, maybe a little more air quality monitoring stations. Now we do not have, like reports and comparison between Novosibirsk and other cities. I mean, in written form, but we can explain the following. Novosibirsk is not that bad, and it's not that good. I mean, it's in the middle. Comparing to Moscow, I believe that they are comparable. But of course, we can see the cities which has really bad or strong problems with ecology. For example, Krasnoyarsk. It's not. We have not. You can't see Krasnoyarsk on this map because it's Krasnoyarsk asked us not to show it. Because it's it's always red or even black, and concentrations are very high. Yeah, and it's again quite sensitive subject, and it's not a joke. And now we try to find the way together with Krasnoyarsk Scientific Center how to explain to the public, and we are going to start public step by step, not to frighten too much this society. So Krasnoyarsk is, it's not a good city. Novosibirsk, Moscow, they are comparable. Speaking about regions in Novosibirsk, we know that I will say the following: the station, which is placed close to. I don't know how to explain in English. This is a plant where electricity is generated. So this station in winter usually shows high numbers. So that's why, here it can be not very good well place for living. Speaking about Akademgorodok, usually it's quite safe. But to be honest, we have to mention the following: that now today we have stations in Novosibirsk. We have stations which measure only concentration of particles, PM2.5, PM10. We have sensors for gases, but we don't have them in Novosibirsk yet. We have them in Moscow somewhere in other cities. And speaking about particles, they behave well. It was unexpected at the beginning. It's understandable right now. I will show you the comparison. So let us take the station from in the center of the city, and well, for example, station somewhere in close to Akademgorodok. It's Lozhok, well, town, city, whatever. Sorry. To comparison, yeah, and let us compare and show the difference. Yes, and you can see that the concentrations of particles correlate well, pretty well. Between these stations, we have like 30 kilometers. And one of the stations is located in Lozhok, and another is located in the central area of the city. Of course, we have some events in the center, you know, short in terms of time, for example. And we do not have these events in Lozhok. But the average level is correlated pretty much, because concentration of particles depends rather on the structure of atmosphere than on intensity of sources of emissions. So it was unexpected for us. So concentrations are correlated pretty much.
Thanks. I think if anyone has another question, let it ask after all speakers, okay? So I hope Dima will stay here for a while, and maybe you will have a chance,
yeah, sure.
To ask another question.
Thank you very much. Yeah, thank you very much again.
Once
Thanks.
again, thank you.